good evening everyone. Welcome to this session, another session on BARC Score Booster series. Today is the third session in the practice series for thermodynamics and applied thermodynamics and fluid mechanics. And I welcome you all to this session. Yes. So I will be waiting for you to join the session. Good evening everyone. I welcome you back for this another session on BARC Score Booster series. Today is the third session for thermodynamics and applied thermodynamics and fluid mechanics. And I hope you all are ready for practice of some few more questions for the subject. Today is the last lecture on this or basically last session on last practice session on the Score Booster series for BARC for this subject of thermodynamics applied and fluid. And from tomorrow onwards, you will have some other subject for the revision or for practice session. Hi, Satyakant Mishra, Vishal Gupta, Ashok, Thirumalai. In the app, we have Vijit, Vikas Prasad, Saurabh Pandey, Shubham, Mia. Hi, good evening all of you, and I hope you all are doing fine. Hi, Vedant. Namaste, good evening. What's the difference between piezometric head and static head? Well, these are the two different approaches, Aditya Srivastav. Piezometric head is defined as the total pressure head plus elevation head. Static head is the total head that we get when the fluid is under static condition, when the fluid is at rest. Okay, so when the fluid will be at rest at some point, it will definitely have some pressure energy and also some elevation. Okay. So we can say that it is almost same, but it is depends on the condition. Okay, piezometric head basically, static head is generally considered for a fluid which is at rest. Okay. Shivam Agrawal is saying that. Oh, thank you so much, Shivam Agrawal, that you are getting 70 marks in the GATE exam, and that is very good. That if you are getting these marks, I'm very happy to see that the hard work that we are putting for all of you is giving you some result. And if you are getting something, yes, definitely you can get an IIT. You have to choose your specialization you have to choose the correct specialization. You will definitely get IIT for your masters. That is your MTech. Okay, Shivam. So very happy to see that you are getting those good marks in the GATE exam. So today is the third lecture in this Score Booster series for thermodynamics, thermal and applied and fluid mechanics. And this is the first question. Ravi, these lectures that are going on in the YouTube or in the app, they are basically in the English language, not in Hindi, because basically the paper that you all have to give, either you give the BARC exam or GATE exam or engineering services exam or SSCJ exam. All the paper will be in the English language, okay? And if you have any problem in understanding any fact or anything, you can then tell me. We can explain in Hindi language, not that much, but yes, we'll try to explain it, okay? Else otherwise, all the things that you have to give, the exam is in English language, the books are in English language, so ultimately you have to study English, right? You cannot run away from it. So this is the first question. It is a very easy question. Today I have got mixture of question. I will be having. I have got easy and tough both kind of questions. Okay. BARC Gradeup test series are sufficient or not? Well, Manpreet, I would say that I cannot comment on that whether our test series are sufficient enough. But yes, if you have time, after going through our test series, after solving the question of our test series, if you have time, you can purchase some other test series, or you can practice. If you want to practice more question, in that case, you can buy other test series also. But for now, if you have purchased a Gradeup test series, if you have practiced Gradeup BARC test series, basically Gradeup green card, then it is sufficient enough. Okay, if you are able to solve all the questions. Saurabh Pandey is getting option D for this question. Ekavaram is quite difficult to pronounce, but Ekavaram, he has got option D. Manoj Kumar is getting option C. Yes. So you have to use the formula in the very, you have to remember the formula for solving this question. It is a very easy question, you just have to remember the formula. We know that in this question they have given in a turbulent flow through the pipe, the mean velocity is 3 meters per second and friction factor is given. If you don't remember the formula, if you don't know the formula, you won't be able to solve the question. So the shear velocity is equal to under root of friction factor divided by 8 into mean velocity or the average velocity. This is the formula for the shear velocity. The correct answer for this question will be option D. Those who have got option D as the answer, that is correct. Okay. Now, if you remember this formula, you can easily get the answer. You just have to put the values. Friction factor is 0.03, mean velocity is 3, and the answer will be 0.18. Okay. So that is why I have taken this question, so that you should remember this formula also for finding the shear velocity for a turbulent flow. Okay. Next question. Next question from basically it is from the concept of drag force or coefficient of drag. Laminar boundary layer flow past the square plate arrangement is shown in the figure. Comparing to the friction drag of a single plate, how much larger is the drag force of the 4 plates together? Yes. For laminar flow, tell the formula. Well, for laminar flow, you don't have to calculate the shear velocity as such. Basically, you have to find the shear velocity only for the turbulent flow case. Solve this question and tell me the answer quickly. So you can see there are 2 plates, 2 configuration of plates is given. In the first figure, it is a single plate, then we have 4 plates together. You have to compare the drag forces in the 2 plates. I hope the diagram is visible to you all. Yes? Is the diagram visible to you all? Manoj Kumar is giving option C. Vedant is giving option A for this question. Oh my God, this is some mistake here. There's a mistake here, I'm so sorry. Whoever has done this. This should be B. This should be B here. This should be C. This should be D. Okay? So that is some mistake. This is option A, this is option A, this is B, this is C, this is D. Now you can tell me what is the correct answer according to you. Okay? So now Ekavaram Rentamalu has got option A. I'm really sorry if I'm not able to pronounce your name in the correct way. Yes, so many students are giving the answer. The correct answer for this question I will be telling. Let me see some more response. I have to see the comments. Yeah. So the right answer for this question is option B. And those who have given option B for this question, that is correct. And how to solve this question? Let me give you the solution for this. We know that we have to compare the drag force. All right. So drag force is equal to half CD rho A V square. Okay, that is the formula for finding the drag force. Now we have to compare the drag force in both the configuration. All right, so we know that drag force from this, we can say that we don't have to, there is no relation for velocity as such. Okay, they are not asking you to compare the velocity. If the plate's configuration are changed, only thing that will change is the area or the length. You can see that drag force is directly proportional to the coefficient of drag and the area. Now, some students will get the wrong answer who will just think that the drag force is only directly proportional to the area, right? Now, you know that this coefficient of drag for a laminar boundary layer, coefficient of drag is directly given by 1.328 over under root of Reynolds number. Okay. Rohan Kulkarni, I think if you want to prepare for BARC, I will definitely tell you. You just have to follow these lecture series going on the YouTube channel for the practice of question. You should please, or you can follow, please solve the previous year gate questions. Okay. And if you have given the gate exam, already you have done the revision of the all the syllabus. You can also revise it again. That is the best thing that I can tell you for preparing for the BARC exam. So, this coefficient of drag is equal to 1.328 for a laminar flow. All right. Now, this Reynolds number, let us say this is also equal to 1.328 under root of rho VL divided by mu. So we can say the coefficient of drag is inversely proportional to the square root of the length. Okay. Now we can say that the total relation of the drag force is not just with the area, it is also with respect to the length. Okay. So we can say that the coefficient of drag is directly proportional to the area and inversely proportional to the length. Okay. So if you have to compare the two drag force, this will be Ft1 over Fd2 will be equal to A1 over A2 into under root of L2 over L1. Now the question is, they have given nothing about the area, but they have given that it is a square plate. Let us say that if it is a square plate, let us say length of the plate is L and area is A for a single plate. Now, for all the 4 plates, the area will be what? For all the 4 plates, the area will be 4A. And what will be the length? It will be equal to 2L. Okay. So we can say that A2 will be equal to 4A and L2 will be equal to 2L. If you substitute the values, you will get this will be equal to A1 is equal to A over 2A into root of 4A into root of 2L over L. This will get cancelled out, this will get cancelled out. You will get 1 by 2 root 2. So the final result that you will be getting is drag force 2 will be equal to 2 root 2 times of drag force 1. That will come out to be 2.83. We can share the formula of drag coefficient of a turbulent flow. See, drag coefficient of a turbulent flow is given by, I think it is that is 0.774 over under root of Reynolds number power 1 by 5. See, all the formula you have to remember, these are basically based on the Blasius equation. I think that is 0.074 over Reynolds number power 1 by 5. Next question, at a point A 2 meters from the leading edge, boundary layer thickness is 3 mm. Another point B has a boundary layer thickness of 4 mm in the same viscous flow. The distance between the 2 points will be. So this question is from boundary layer, concept of boundary layer. Yes. Yes, come on guys, solve this question, tell me the answer. So distance from the leading edge, basically if you see the flow of the boundary layer over a flat plate, as soon as you start as the boundary layer grows over the flat plate, the beginning of the boundary layer, it is called a leading edge, and the last end of the boundary layer of the plate is called trailing edge. Okay, so it is saying that at a point A, 2 meters from the leading edge, the boundary layer thickness is given here. Similarly, at point B, the boundary layer thickness is given as 4 mm. You have to find the distance between the 2 points. Hi Gyanendra Pandey, very good evening to you. So the right answer for this question is Arpit Mathur is giving 1.55, Vijay is saying option A, that is 1.55. Chetan Patil has also got option A as the answer. Tushar has got option A, Kunal has got option B, Aman Kumar option D, Deepak Kumar option C. The correct answer for this question will be option A. Those who have got option A as the answer, that is correct. Very good. So let us say this is a flat plate. Let us say this is a leading edge, point A. Now distance from the leading edge at around 2 meters from the leading edge, the boundary layer thickness is equal to 3 mm. Okay. And at some distance at point B, the boundary layer thickness is equal to 4 mm. You have to tell this distance, the distance between the 2 points. You have to find this. Okay. Now how to solve this question? Now one thing that you have to, for solving the relation for boundary layer thickness and the distance from the leading edge, firstly you have to find whether it is a laminar flow or turbulent flow. So can you tell me whether it is a laminar or turbulent flow? Yes. Can you tell me whether it is a laminar or turbulent flow? Guys, can you tell me whether it is a laminar or turbulent flow? Those who have got option A as the answer, that is correct. Assume to be laminar. You don't have to assume Adit Srivastav. They have given it is a viscous flow. Viscous flow. Another name of viscous flow is laminar flow. Another name of viscous flow is laminar flow. Okay, another name of viscous flow is laminar flow. Highly viscous flow is called laminar flow. And for a laminar flow, delta is directly proportional to square root of the distance from the leading edge. And for a turbulent flow, it is directly proportional to x power 4 by 5. This is for turbulent flow. And this relation is for the laminar flow. Okay. So it will be good if you remember this relation for laminar and turbulent flow boundary layer thickness. It will be very much helpful for solving the question directly. Okay. So the value of boundary layer thickness delta 1 by delta 2, so delta A by delta B will be equal to under root of square root of XA over XB. Okay. So from here you can find the value of XB. So that will be delta A, that is 3 by 4 is equal to under root 2 by XB. From here you will get the value of XB. And what you have to find? You have to find XB minus XA. So if you will get the value of XB, you will find the value of XA. That will be, I think, 3.55. And if you subtract 2 from there, you will get this value as 1.55. Okay. So that was a good question. Next question, a pump having efficiency of 85% is running at a speed of 4800 RPM and delivers 2.5 meter cube per second of water under a head of 20 meter. Okay. The power input to the pump at a shaft speed of 1600 RPM under the same head has to be determined. Arpit Mathur, I have told you the relation for delta and x for turbulent flow already written in that previous slide. That is x power 4 by 5. So we have to find the power if the speed is varying and the head is same. Firstly, you have to remember the relation for the power and the speed. Yes. Arvind Bhadoria is giving option B for this question, okay. So I have to check whether the answer is correct or not. Yes. Yes, anyone else who has solved the question? Sai Rohit has got option D. Pankaj Kumar has got option A for this question. Anyone else who has solved the question? UPSC MEC has got option A for this. Deepak Kumar has got option D in the app. Ajay Chaurasia has got option D. Power is directly proportional to cube of the speed. Yes, very good. So those who have got option D as the answer, that is correct. The right answer will be option D. The power is directly proportional to n power cube. Okay, so we can say that P1 by P2 will be equal to N1 by N2 whole cube. But the question is how to find the initial power? Is initial power is given in the question? No, it is not given. So firstly, you have to find the initial power. Okay, so that can be found by overall efficiency is given in this question. A pump is having the efficiency. A pump is having the efficiency. If nothing is mentioned, it has to be taken as overall efficiency, that is 0.85. That is given here 0.85. Now we are talking about a pump. If we talk about overall efficiency of a pump, what it will be the overall efficiency? It will be the ratio of the overall efficiency of the pump is equal to ratio of the water power over shaft power. Okay, it is just opposite to the overall efficiency of a turbine. Okay, now water power is equal to rho G Q H divided by overall efficiency. All right. So from here, one second. That should be shaft power. So from here, the shaft power 1 will be equal to rho GQH divided by overall efficiency. So from here you will get the shaft power for the first case when the speed is 4800 RPM. Okay. So after getting this shaft power 1 from this relation, you just have to substitute the values. The N1 is equal to N1 here is N1 is 4800 and N2 is 1600. Okay, so you have to find the value of the power when the speed goes to 1600. Obviously, the power, as the speed will lower down, the power will also be less. Okay, so the answer will be option D for this question. Those who have got option D, that is correct. Next question, in a vapor compression refrigeration system, refrigeration effect is 40 kilojoule per kg and the coefficient of performance of the system is 4. Then find the heat rejected in the condenser. Why can't we take the relation from the specific speed? Which specific speed are you talking about? N root Q H power 5 by 4. See, in this question, Chetan Patil, there are so many relations that we use for turbines and pump. It depends on the question, what is given in the question. In the question, they have not directly given you the power, input power. Okay, overall efficiency was given there, so you have to find the shaft power from there. Now, how we are getting that relation for power and speed? Power is equal to, there is a relation for power and speed that is, that should not be compared with the specific speed. Okay, that should be, because if we talk about the specific speed of a pump, that is N root Q H power 3 by 4. Okay, So there is no relation of the specific speed for the pump and the power. It is only with respect to discharge. Okay, so the relation that you will get from, that is not from there. Arvind Bhadoria has got option B, Pankaj Kumar got option B, Shivang has got option B, Karan Arya option C. The correct answer for this question will be option B. Those who have got option B as answer, very good. So how to solve this question? For solving this question, we know that coefficient of performance is given to you 4. It is a very, very easy question. And those who have not got this question correct, that means your concepts are really very weak. You need to revise and brush up your concept. Okay? So coefficient of performance is equal to refrigeration effect over work input. You know this? It is equal to desired effect over work input. Alright. So in this question, the refrigeration effect is given to you 40. So work input from here you will get as 40 over 4, that is 10. So that will be the work input. Now we know that if we are talking about the refrigeration system, in the refrigeration system, the work input is equal to heat rejected by the condenser minus refrigeration effect. Okay. So from there heat reaction will be equal to what? Work input to the compressor plus refrigeration effect. So that will be equal to 10 plus 40, which will be equal to 50 kilojoule per kg. Okay. Hi Ankit Jaiswal, very good evening. Well, it is not always that you have to apply the formula of the power with as directly proportional to n cube. It is given in the question that head is same. Head was given as same, and also the pump, they have not specified about the dimension of the pump. That means we have to take the diameter of the pump also as same. In that condition, yes, the power will be directly proportional to cube of the speed. Next question. If air entering the cooling coil of surface temperature 10 degrees Celsius with the mass flow rate of 20 kg per second, inlet condition of the air is 30 degrees Celsius, dry temperature, specific humidity is 0.0182, enthalpy is given as 75 kilojoule per kg of dry air. Okay. Outlet condition also given, you have to find the amount of water vapor condensed. Again, a very good concept. If you don't know the concept, you won't be able to solve the question. Yes, solve this question, read all the values given here correctly and apply the right formula and get the answer. I am giving you 1.5 minutes for solving this question, because maybe you have to take some time for reading the question carefully and then tell me the answer. Yes. So you need to understand that it is a question of psychometry from refrigeration air conditioning. And one thing that you have to also understand, they are asking about the amount of water vapor condensed. Now condensation is a phenomena which take place due to change in temperature or due to change in some other thing. That you have to understand. Okay. And accordingly you can solve the Avinash Mule has got option C, Arpit Mathur has got option C, Mahesh Singh has got option C, Mahendra Sirve has got option C. In the YouTube I can see Manoj Kumar, Shubham Agarwal, Tushar has got option C. Anyone else? Basha has got option C. Adarsh Srivastava has got option C. Okay. So many students have given the answer. That is correct. 8.64 kg per minute will be the value of the amount of water vapor condensed. Now, if you see the psychometric chart, we know that if we have to find the amount of water vapor condensed, this is specific humidity. Specific humidity. And this is dry bulb temperature. Now, if I'm saying that water vapor amount of water vapor condensed has to be found. Water vapor condensed basically is related to the specific humidity. Amount of specific humidity determines the water vapor content. Specific humidity actually determines the amount of moisture, and when condensation will take place, the water vapor condense has to be determined by the relation amount of water vapor condense will be equal to m into mass of the air which is entering the coil into the specific humidity at the inlet minus specific humidity at the exit, because we know that specific humidity increases in this direction. Okay, so when condensation will take place, definitely it has to be the difference of the specific humidity at point 1 minus specific humidity at point 2. So that will be the answer. We have to take it as 20 into 0.0182 minus 0.011, and you will get the now you will get the answer in 0.14. I think you will get this value as 0.14 kg per second. But you don't have to find the value of amount of water condensed in kg per second. It has to be found in kg per minute. Okay, so you have to convert this value in kg per minute by multiplying with 60. Then you will get the answer in kg per minute, that is 8.64 kg per minute. Okay. Just confirm me whether you are getting the value as 0.14 kg per second. Yes. But here dry bulb temperature is different. Yeah, I totally understand dry bulb temperature is different. That is why it will be equal to m into W1 minus W2. That is 30 and 20. So dry bulb temperature is actually changing from 30 to 20. So we can say that. See, basically dry bulb temperature is changing, the enthalpy is also changing. But tell me, frankly, you just tell me that if I am talking about condensation, if I am talking about condensation phenomena basically take place when the specific humidity will change. It is basically related to change of specific humidity. Other values are given, but they are just, see, in the gate type question, most of the values will be given to confuse you. That is correct, Ankit. Most of the values will be given just to confuse, so that you get confused in the what is given and you get involved in the question. You have to read it correctly. You have to find the water vapor condensed. Condensation phenomena is related to the change in specific humidity. Okay. So obviously you have to use only these two values. Next question. A stream of 1 kg of moisture at 20 degrees Celsius, specific humidity is given, and dry air mixes with another stream of 2 kg of moisture. You have to find the value of specific humidity of the mixture in gram per kg of dry air. Condensation is a phase change process. It has nothing to do with the temperature. Okay, yes, that is correct. Condensation is of latent heat, is a process in which temperature has got no role. Okay. Temperature, it takes place, all the phase change process take place at same constant temperature or saturation temperature. So read this question carefully. You have to find the specific humidity of the mixture in gram per kg of dry air. Again, I would suggest you to read the question carefully. They have asked you to find this value in gram per kg of dry air. Avinash Mule has got option A. Arpit Mathu has got option A. Indra Patel, what is the answer? Indra Patel, okay, A is the answer, all right. So most of the students have given the answer. In the YouTube also, I can see Tushar, Sai Rohit, Pradeep, Satyakant Mishra, and Anurag Shukla has got option A. Very good. The correct answer will be option A. How to solve this question? Again, it is a mixture of two streams are taking place. So when two streams are mixing together to give the third stream, let us say this is M1, W1, M2, W2 and M3 W3. We have to remember that M1 plus M2 will be equal to M3 and M1 W1 plus M2 W2 is equal to M3 W3, where W is the specific humidity. So in this question, firstly you have to find the total mass. Total mass will be equal to the mass, here it is given as 1 kg, here 2 kg, the total mass M3 will be equal to 3 kg. Okay. And W1, W2 is also given here for both the cases. You just have to put all the values in this formula and you will get the value of specific humidity for the mixture, that will be 0.014 kg per kg of dry air. But we have to find it in gram per kg of dry air. So it have to be multiplied by 1000. So that will be 14.4 gram per kg of dry air. Okay. So correct answer will be option A. Next question, in the Rankine cycle for a steam power plant, the turbine entry and exit enthalpies are given. See, this question is very important because the formula that is given here for specific steam consumption, so many times it has been asked to find the specific steam consumption in the question, in the exam. Either you see GATE exam or if you see any other exam, if you're talking about the BARC exam, in that also the question will be very similar to GATE exam. So the specific steam consumption is very, very important. You just have to remember a single formula for that. In pump power calculation, previous one, I used specific speed formula of pump to calculate the discharge having same head and then calculating power by using rho g QR, but I'm not. See, Shivam Agrawal, it's not that you can use any approach to solve a question. If that is the thing, we have so many formula for the laminar flow in the pipe and and also if you talk about turbulent flow, there are so many correlation. So for solving a question, it's not that you have to use any kind of approach. In that question of pump, firstly you have to find the power, shaft power. For finding the shaft power, why are you using the specific speed formula? It is a pump, and for pump N specific, it is equal to N root Q H power 3 by 4. Okay, head is same. Why are you calculating the discharge? I am not able to understand this thing. There is no need to calculate the discharge. So that is one thing that you should not try to get confused with the formulas. There are so many formulas in the subject of this hydraulic turbines and pump. There are so many correlation for model turbine and pump. Okay, you have to use it very wisely that which formula has to be applied. So if you are calculating the discharge and then going on for further calculation, that is not the right way. You have to find the shaft power. Yes, sir, I am saying also that after calculating discharge and then Shivam Agrawal, I will definitely take your question. Okay, firstly let me give you the solution for this. The right answer will be option B. Okay, those who have got the answer, very good. Now let me tell you further that this Rankine cycle you have to just use specific steam consumption, that is 3600 over net work output. Net work output is equal to turbine work minus pump work. So what is turbine work, pump work? It is equal to difference of the enthalpies. The enthalpy values are given at the entry and exit of the turbine, that is 2803 and 1800, and also given for the pump. So turbine work will be equal to, that will be 2803 minus 1800, and pump work will be equal to 124 minus 121, that is 3. So this will be 1003. If you subtract, you will get this value as 1000, and this will be 3600 divided by 1000, which will be 3.6 kg per kilowatt hour. Okay. Now let me first take the query of Shivam Agrawal. He was having so much queries about this, so I don't want anyone to have any confusion in the mind. Hey Shubham, one thing you have to check here, that discharge is already given in the question. you don't have to calculate the discharge. It is already given in the question. That is 2.5 meter cube per second. So why you have to calculate the discharge, I am not able to understand. Okay? So if discharge is given, just you have to calculate the power and you apply the relation. And one more thing, Chetan Patil is saying P by D power n cube. I know this is a formula. In this question they have given that the speed is same. In this question they have given the pump are having the same head. Sorry, same head is given and nothing has mentioned about the dimension of the pump. So we have to take that, we have to assume that if the head is same, the diameter is also same. We have to do the assumption in that case. If nothing has been mentioned about the dimensions of the pump, we have to take it as same. So diameter has to be taken as same. That is why the power will be n power cube. Because we know that it is the relation P over D5 n cube. Nothing has been mentioned about this will be get cancelled out. The power will be directly proportional to n cube. Only for this condition. Next question. The steam at 40 bar 500 degrees Celsius flowing at the rate of 1.5 kg per second expands in a high pressure turbine to 2 bar with an isentropic efficiency of 80%. Determine the enthalpy of the steam of the exit of the high pressure turbine. Okay. You have to find the enthalpy of the steam in kilowatt. Just take care of the unit. Vijit, sorry, you have given your suggestion at the very last end. Today is the last session for this thermodynamics and applied thermodynamics and fluid mechanics session for BARC exam. And I already have taken the question. If you have done your suggestion earlier, that is on the previous 2 days, I would have definitely taken such kind of question. Okay, but if I talk about the question involving combination of the piston and linear spring, such kind of question are given in the PK Nag. If you have got PK Nag book, you can practice the question from there. Okay. Pawan Kalyan, PK Pawan Kalyan has got option C for this question. That is 2692.04. Anyone else? Is anyone else there who has solved the question? Tree is life has got option C. He is very confident. So he has typed it so many times. Very good. Okay, I will be waiting for you. Is your previous videos playlist is available? Yes, definitely it is available on the video of Gradeup channel, YouTube channel, and also in the Gradeup app. If you are using the Gradeup app, you will find these previous lectures of thermal and applied and fluid mechanics for BARC score booster series in the free video series of the Gradeup app. Okay, so in that particular section, you can find the other videos of practice session for these subjects. Yes, very good. Those who have got option D as the answer, that is not correct. The answer will be option B. Those who have got option B as the answer, that will be the correct answer for this question. Chetan Patil, you can access this lecture for the free series in both YouTube and Gradeup app. In the Gradeup app, you will find these lecture in the free series section, free video series section, and in the YouTube channel, you can find this lecture in the playlist. Okay? So correct answer will be option D for this question. Those who have got option D as the answer, that is correct. So how to solve this question? Yes. How to solve this question? It is a question from a steam turbine. That is, you have to draw the Rankine cycle. Now, they are asking you to find the value of they are saying that the turbine is having isentropic efficiency. Let us say it is having some isentropic efficiency. So let us say this is 1, this is 2S, this is 2. this is 3, this is 4. We can take the cycle in any direction. Okay. So you have to find the enthalpy at the exit of the turbine in kilowatt. High pressure turbine in kilowatt. Okay. Now, we know that isentropic efficiency is given here. So if isentropic efficiency is given, which is 0.8, then this has to be equal to actual work over isentropic work, right? So that will be actual work. What will be actual? That will be H1 minus H2. And what will be isentropic? That will be H1 minus H2S. Okay. Right? Now, one thing that you have to understand in this question, the value of H1 is at what? At 40 bar and 500 degrees Celsius. That means at 40 bar and 500 degrees Celsius, this value is the value of H1, which is given. So that means these two values are known to you. You have to calculate this value and this value. Ultimately, you have to find this value, which is the actual value of the enthalpy. Actual value of the enthalpy will be this. This you have to find. If isentropic efficiency is given, then you have to find the actual values. You have to find the actual values, not the isentropic values. You don't have to find this actually for the answer. Actually, you have to find this value. Okay. So for finding this value, you have to find this value first. How you can find that? We know this. We know this, that the value of, in 1 second, the value of, now this is not a case of Brayton cycle that you can find it by with respect to temperature. So for solving this question, you have to find the value of H2S. H2S, let us say that it is in the wet region. It is not correctly drawn, but this is basically written here. It is 2 bar, and the value of a specific volume of the values are given here. That means it is in the wet region. This point is in the wet region because the values are given here for the wet region also. That means 0.2S is in the wet region. And for the wet region, we know that S1 will be equal to S2. We have to find the value of dryness fraction. H2S will be equal to HF plus X times of HFG, which is Hg minus HF. So this value is given here. HF value is also given here. Okay, you have to find the dryness fraction. And for finding the dryness fraction, we have to use this relation. Because it is an isentropic process. 1 to 2 is isentropic process. So we can say that S1 is equal to S2. Now S1 is at what condition? This is given as 7.09. So this is 7.09 is equal to, SF is given here, that is 1.503. 1.503 plus X times of Sg minus HF, that is 7.12 minus 1.503. So by solving it, you will get the value of X, which will be 0.993. So you will get the value of dryness fraction as 0.993. Okay, are you getting the value of dryness fraction? 0.993? Very, very close to 1. Very close to 1. Okay. It doesn't matter, but you have to find the dryness fraction, right? You have to use the correct approach for solving the question. Right, Subham Agrawal? So, and actually if you don't use it, I have to tell it. Okay, because maybe in the other question, the dryness fraction can come to be 80%. It is not necessary that it will be 0.993 every time, right? So I have to tell you the approach. So you have to put the value here. The H2S value will be equal to 504.7 plus 0.993 into HF, Hg minus HF, that is 2707 minus 504.7. By solving it, you will get the value of H2S. H2S value will be equal to 2691.58. Now you have got the value of H2S, but you don't have to find this. You have to find the value of H2 because it is an isentropic efficiency is given here. So you have to put the values of H2S here. You will get the value of H2. That will come out to be 2842.26. 2842.26. But this value will be in kilojoule per kg. The value that you will be getting here is kilojoule per kg. But the question is, they are not asking you to find the value in kilojoule per kg. They are asking you to find the value in kilowatt. Okay. Okay, Shubham Agrawal, I totally understand what you were saying. Totally understand it. So, the answer is in asked in kilowatt. But the value is in kilojoule per kg. So, how we can find in kilowatt? The mass flow rate of the steam is given 1.5 kg per second. And we know that if kilojoule per kg is multiplied with kg per second, it will be kilojoule per second, which is kilowatt. So, you have to multiply with 1.5 and you will get the answer as 4263.4. Understand? So, that is how the question has to be solved. Alright. Next question. And if I am not wrong, this is also the last question of today's session. In a simple Brayton cycle, the pressure ratio is, that should be ratio. There are so many typing mistakes, I am really sorry for that. The pressure ratio is 6 and the temperature at the entrance of the compression turbine are given here as 400 Kelvin and 1500 Kelvin. Both compressor and gas turbine have isentropic efficiency equal to 0.7. For the gas, assume a constant value of Cp, that is equal to 1 kilojoule per kg Kelvin, and the ratio specified as this. Neglect the changes in kinetic potential energy. You have to find the value of power input to the compressor in kilowatt per kg of the gas flow rate. Solve this question and tell me the answer. Again, this question is, this time it is from Brayton cycle. Isentropic efficiency is mentioned. So solve this question and tell me the answer. I am giving you 1.5 minutes for this question. Yes, I think today we have, this is the 11th question for today's session. I think today we have solved around 11 questions. That is quite a good number. So we know that what is power input to the compressor? It is equal to rate difference of the enthalpies. But which enthalpies? They have given isentropic efficiency, so you have to find the difference between actual enthalpies. Okay? So take care of that and solve the question, tell me the answer. Chetan Patil has got option C as the answer. Satyakant Mishra has got option C. That is 382. Anyone else? Mahendra Sirvi has got option C. Gulam Raza has got option C in the YouTube. Anyone else? Okay, Satyakant, totally got, understand that you have got 382. Sai Rohit has got option 382, that is option C. Tushar has got option C. Anyone else? Last call for this question. Shubham Agrawal has got, okay, Shubham, have you solved the question? Pradeep has got option C for this question. Abhinandan Kumar has got option C. Shubham Agrawal has got option C. Okay. So I have given you time and the right answer is option C, that most of you are correct. I think everyone has got option C. Very good. So for solving this question, firstly you have to draw the Brayton cycle. It is very easy to get the answer or solve the question correctly if you draw the diagram, especially for these cycle questions, Rankine cycle, Brayton cycle. Try to draw the diagram. It will be very easy for you to understand the question. Okay, so they have given, it is 1, 2, 3, 4. Now, but they have given the value of isentropic efficiency for both compressor and gas turbine. That is given here. This is 2S, this is 2, this is 4S, and this is 4. Because they have given isentropic efficiency in this question. They have given the isentropic efficiency in the question. Okay. So if they have given the isentropic efficiency in the question, For solving the question, you have to apply the formula of isentropic efficiency. But you have to find the power input for the compressor only, not for the turbine. That is a good thing. The calculations are not that lengthy. You just have to find the power input to the compressor, which will be equal to M. Do we have to use the mass flow rate? Because they are asking you to find the value in kilowatt per kg. So if you don't use the mass, that is also okay, that is fine. That will be equal to H2 minus H1. H2 minus H1, simple. Now, we don't need turbine data, that is correct, very good. We just have to find the power required for compressor. But we have to find the value of H2, not H2S again. But it is a good thing that we are solving the question for Brayton cycle. Brayton cycle uses working fluid as gas or ideal gas. And if we have to find the value of enthalpy H2S, we have to find the enthalpy H2S, right? For finding the value of H2, we have to find H2S, because isentropic efficiency of the compressor will be equal to H2S minus H1 divided by H2 minus H1. It is just opposite to turbine. Okay. Now, the value of this value has to be found with respect to temperature. So we know that T2S by T1 will be equal to P2 by P1 over gamma minus 1 over gamma, right? Because see, in that question of Rankine cycle, we cannot solve it by using temperatures, right? Although in that also compression expansion both are isentropic. But here in this particular case of Brayton cycle, we can convert this enthalpy in terms of temperature. Why? Because we know that it is a case of a Brayton cycle. So we know that enthalpy will be a function of temperature. So we can say that this work power will also be equal to Cp times of T2 minus T1. And this will also be equal to what? T2S minus T1 over T2 minus T1. T1 is given here 400 Kelvin. You just have to find T2S. And T2S can be found by the equation of ideal gas for a isentropic process. Okay, and this is the equation for an ideal gas for isentropic process. T2S by T1, that is T2 by T1 is equal to P2 by P1 gamma S1 over gamma. P2 by P1 is the pressure ratio given here as 6. So you have to put the values here, T2S over 400, which is given here, is equal to 6 power 1.4 minus 1 over 1.4. This value, if you will be in a regular practice of solving the question, this value is equal to 0.2857. Okay, so if you are in a regular habit of solving the question, if you know that 1.4 minus 1 over 1.4 is equal to 0.2857, you will get the value of T2S from here, and that will be equal to, what is the value of T2S you are getting? T2S will be 667.3. That will be 667.3 Kelvin. That will be the value of T2S. Now, the value of T2S has to be put over here. T1 is given here, and this is given as 0.7. So from this relation, you can find the value of T2. It is very easy to find the value of T2 from here, right? Can you find the value of T2 from here? That will be very easy. It will be very quick. So T2 value can be found from here. That will come out to be T2 will be equal to 781.98 Kelvin, approximately 782. Now you have to find the power output of the compressor, which will be equal to Cp is given here as 1. So that will be 1 into 781.98, approximately 782 minus 400, which will be 382 kilowatt per kg. Understand, everyone? Understand? So correct answer will be option C. That is how the question has to be solved. I hope you all have understood all the question and the solutions, right? So that is the last question for today's And also the last question for the score booster series from thermal and fluid mechanics. And so from tomorrow onwards, some other subjects have to be taken in the score booster series. I hope in my 3 lectures, I have tried to cover around 25 questions from fluid mechanics and thermal and applied. Okay? And I also tried to cover different topics from these subjects. So maybe I was able to clear your doubts. When will be next class? Next class will be from tomorrow onwards, every day at 5:15 p.m. Okay, but not my class, because my subjects have been completed. Now other faculties has to take their subjects. Okay, before I end this session, let me firstly take some reply, some questions. Shivam Agarwal is having some question. Yes, please ask your question quickly so that I can explain you about Vision 2021 course. That is also very important, especially for those who are thinking about cracking GATE and Engineering Services 2021 exam. Okay, so if your vision is to crack GATE and EAC 2021, you just have to join this Vision 2021 batch 2 by Gradeup. Batch 1 has already been launched and the enrollment has been closed for that. How to contact me? See, it's quite difficult. See, basically Gradeup faculties are not, usually I cannot share you my contact details. But yes, if you want, if you have any queries, you can contact at a mail ID. You can contact me at vikas.bhadoria@gradeup.co. But I cannot write it so that I don't want more students to, basically it creates a lot of problem. So if you want to contact me, you can mail me at vikas.bhadoria, bhadoria@gradeup.co. That is my mail ID. You can contact me from that. Okay. Any other else query? From where I have done my masters, I have done my master's from Thapar University, Patiala, and that is a long story why I have chosen my masters from that college. Although I was getting an NIT for my MTech, I have left that and I have gone to Thapar because actually I was interested in taking thermal branch, and actually I have got lot of interest for thermal. So that is why I have left that college, NIT. And because I didn't want to pursue my master's in manufacturing, so I thought it was a better option to go for thermal in, and Thapar University is a good college if you are thinking of pursuing your master's. If you are not getting any college, especially IITs, then if you compare NITs and Thapar, it is also a good college. Okay. Can we use isentropic formula to find the work input of compressor MR T2 minus T1 gamma minus 1? Arpit Mathur, no, it is. See, basically power input of the compressors, power input of the compressor will be in terms of difference of the enthalpies, which is equal to Cp of T2 minus T1, according to the ideal gas theory. Okay. Yes, yes, Raghav, Rishabh Kashyap, Thapar University takes student by GATE score only. I have also done my master with the help of GATE score and also got the scholarship of 12,400 like other students. It just difference. The difference is only that is a private college and NIT are government college. But hardly matters if your college is good, if your faculties are good, and if you are actually learning something. It doesn't matter from where are you pursuing a master's. Okay, and let me tell you, I have done such a lot of extensive research in my master's. I have visited around 30 industries and 8 to 10 power plants. Okay, so that is quite a different research methodology that is followed over there. If we compare the other college, that is basically not present in other colleges, especially some NITs and IITs, what I have felt. So if we compare the other colleges, it is a very good college. Especially the faculties are also very good. So let me not discuss about Thapar and comparison of other college. We can have a separate session for that. Okay. So firstly, let's focus on this information. It is very important information. Those who want to prepare for GATE and Engineering Services 2021 exam, you can join this course. The name is Vision 2021. Okay, in this course, we are going to cover the complete syllabus. It is a 1.5 year long course in which complete syllabus of GATE and Engineering Services will be covered. Okay, and not only technical, the non-tech syllabus of the engineering services will also be covered. Okay, in this syllabus. Along with that, you will get the daily quizzes and conventional assignment for practice for ESC conventional paper. and subject test and full length mock test will also be provided you with this course. The classes will take place in the evening, so those who are working and college going students, they can also purchase the course, they can also attend the live classes, because you don't have the problem of attending the sessions as the classes are going to have in the evening. Okay, so that is the information. The cost of the course is right now, after due to early bird offer is going on, so it is around 24,000. And some students who have qualified the GATE exam, okay, in 17 to 20, they can get this course at a discount of 50% on the MRP. Okay, so that is a very important information. All the GATE qualified students from 17 to 20, they can get the discount of 50% on the MRP of the MRP, which is right now 24,000 approximately. You can get this at 50% discount. Or if you have pursued your BTech from IIT, NIT or any government college, then also you can avail this 50% discount on the MRP. Or if you have qualified the ESE prelims paper, then also you can get this discount of 50%. If you satisfy any one of the criteria, you can get the discount. Okay. If you want to have more information for this, you can contact on this number. Okay. Or you can drop a mail on help@gradeup.co or anand.pandey@gradeup.co. These are the source of your contact for the Vision course. Any query regarding the course, just contact them. They will definitely be in touch with you. And so that is all. If you have any other queries, like some of the students are having any technical query, if I am not able to give my contact details, you can mail your query on anand.pandey@gradeup.co, and if he will definitely forward that query to me. Okay. So if you have any technical query from the subject for the BARC exam, you can just mail it to this mail ID, that is anand.pandey@gradeup.co. That is the mail ID of our admin. So he will forward the doubt to me and I will definitely reply to you. Okay. So that is the source of contact for you if you want to contact me for any query related to technical subjects. Okay. And also this is a mail ID for the Vision course also. So that is all in this session. If I attempt a 65 correct question in BARC, do I have chance in BARC interview in mechanical? See, Arpit Mathur, it is, if you talk about the BARC exam, it is not, I would say that yes, if you are attempting 65 questions, out of 100 questions, if you are able to attempt 65 questions, that is a very good, that will be very good if you answer them correctly. Okay. And yes, you will definitely have a chance to go for the interview in that case. So those students who have done their preparation for the GATE exam and due to some reason were not able to perform well in the GATE exam, this BARC exam is a wonderful opportunity for you to again revise your concept, practice the questions and come back in the competition. Okay. So the paper will be around from 13th to 18th, I think for the BARC exam. Sufficient time is there for you. Revise all the subjects, practice the question again, just solve the previous year GATE question and attend our BARC score booster series session like have been conducted today. Okay. So that is all in this session. If you have any other query, you can ask me. Ankit Jaiswal is having some doubt regarding strength of material. Well, Ankit Jaiswal, I think I am not the correct person for that, because basically I normally deal with the subjects of thermal and fluid. Okay. But yes, there will be a faculty who will be coming for the subject of strength of material, machine design and the other subjects. You can ask your queries related to these subjects to those concerned faculty. Okay. They will definitely reply you in the best possible way. How to get the BARC previous year paper will be, okay, so I will definitely try to search it out if we have some BARC previous year paper, and we will try to upload it in the Gradeup app. If we'll have the papers, we will definitely try to upload in the Gradeup app. Okay. So I will definitely contact my team for that. If we are having some papers, previous year paper for BARC, we'll try to upload it in the Gradeup app. Okay. By attempting 37 questions in the GATE, can I qualify GATE? Rishabh Kashyap, GATE exam is not about attempting 37 questions. We have total 65 questions, and I would never suggest anyone to attempt such a less number of questions. See, If you are talking about technical question, that you want to attempt 37 question, yes, that is good. Okay, but if you are talking about total 65 question, see, you should try to attempt as much as correct questions without any negative marking. Your score will you will definitely be in the safe zone. Okay, so that is all in this session. I hope you have enjoyed solving the question of thermal and applied and fluid mechanics with me from the last 3 days. And only suggestion that I would like to give you from my subject, please revise all the concept, okay, for thermal and applied. If you are good in the concept and if you have actually done the practice of the questions, you are definitely going to score all the question correctly, okay, especially about thermal and applied. And if I talk about the fluid mechanics, yes, it is bit conceptual as compared to the some topics are bit conceptual, but yes, if you have done the complete revision and practice, you are definitely going to nail it. Okay, so that was all about my subjects. Some other faculty will give you the strategy of their subjects, and I wish you all the very best for your BARC exam. I'll meet you in some other session, maybe general session of BARC. Till then, thank you and have a good day. And I can see most of the students are having their queries. 73 marks, kuch nahi mil sakta. Well, SK, if you are getting gate 73 marks in the gate, I'm so sorry, but as per the previous year trend, the students who have got 80 marks, even they are not getting a good call from a good PSU. Okay, so the competition is really very tough. But I would not say that you should lose hope. You should try to, you should also try to enroll for your masters in the IITs, and you will definitely get a good college for your masters. Okay, so I would not. Sir, why don't to put wise question from the? Why don't to put wise question from students? So, Ravi Teja, I am not able to understand what you want to say in that question. Only privacy with you and the students. The reason is that why I personally prefer to maintain the privacy with the chat, because sometimes the students are instead of talking to the teacher, they actually get involved with talking to each other. Okay, they actually involved in conversation with each other. So that is why I usually avoid this public chat. But if you want, next time I will definitely make it available for you. Okay, so that is all in this session. Yes, what is your question? Muare Ahirwar, what is your question? How much gate previous year question solved? See, if you want to if you want to practice the question for BARC exam, you should try to solve the previous year gate question at least from 2010 to 2020. Okay, that is my suggestion. Okay, and I think the time which is left for your BARC exam is only the time left for the practice. So try to practice the question, try to practice previous year question, gate question, previous year BARC question, and the test series. That is all we have. You have to do for your preparation for BARC exam. And that is all I have to say in the end. And I think sufficient time has been taken. Maybe some other faculty has to take the lecture in the same class. So I think the time has already been taken. I'll see you in some other session. Till then, thank you and have a good day. And I wish you all the very best for your BARC exam. Okay, thank you and have a good day. Prep smart, score better. Go Gradeup. Thank you.